Uranus's tiny secret, JWST, spots a new moon in the ring's shadow. Hold on to your telescopes, space fans. NASA's James Webb Space Telescope has just unveiled a pint-sized powerhouse orbiting Uranus, a moon so small you could stroll its surface in a couple of hours, hiding, in plain sight, outside the planet's iconic rings. Dubbed S-2025-U1, this 6-mile-wide speck is the 29th confirmed satellite of the ice giant, discovered in JWST images from February 2025, and announced in August, challenging our views of how Uranus's ring system and moons interplay. In a universe where cosmic giants dominate headlines, this minuscule moon steals the show, potentially holding clues to ancient collisions or captured asteroids that sculpted the planet's ethereal architecture. Stick around as we dive deep into this discovery across 10 paragraphs, from JWST's eagle-eyed tech to the moon's orbital dance, proving that even in the outer solar system, surprises lurk in the shadows. If Uranus's enigmas have you hooked, like and subscribe for more cosmic reveals. The rings might hide more than we think. The discovery of S-2025-U1 marks a milestone for Uranus exploration, the first new moon identified since 2003's S-2003-U3, bringing the total to 29 satellites around the seventh planet from the Sun. Announced on August 19, 2025, by a team led by planetary scientist Mariame El Moutamid from the Southwest Research Institute, the moon was spotted in near-infrared images captured by JWST's NER-CAM, near-infrared camera, on February 2, 2025, during routine observations of the planet's rings and atmosphere. Unlike Voyager 2's 1986 flyby, which confirmed 5 major moons and hinted at rings, JWST's advanced coronagraphy and sensitivity to faint infrared glows pierced the planet's hazy veil, revealing this tiny orb lurking just beyond the main ring system. El Moutamid's team, using data from multiple filters spanning 1 to 5 microns, confirmed the moon's motion across consecutive exposures, ruling out artifacts or noise. At approximately 10 kilometers, 6 miles in diameter, smaller than Manhattan and comparable to a large asteroid, S-2025-U1 is one of Uranus's smallest moons, orbiting at a distance that places it in the planet's outer ring region, where irregular satellites like Puck and Belinda reside. This find, detailed in the Astronomy and Astrophysics paper, underscores JWST's prowess for outer solar system studies, where faint, icy bodies blend into the background, offering a fresh glimpse into Uranus's dynamic past. JWST's NIR-CAM, with its 2.2 megapixel detector and adaptive optics correcting for Earth's atmosphere, though space-based it benefits from precise pointing, was key to spotting S-2025-U1 amid Uranus's faint rings and 13 other moons visible in the images, including classics like the Titania and Oberon. The telescope's near-infrared sensitivity excels at detecting cool, icy surfaces reflecting sunlight weakly, capturing the moon as a yellowish point against the planet's blue-green haze, caused by methane absorption in its atmosphere. El Moutamid noted that the moon's position outside the rings suggests it could influence their structure through gravitational perturbations, potentially explaining asymmetries or shepherding particles into stable orbits much like Prometheus and Pandora sculpt Saturn's rings. The images, processed to subtract the planet's glare, revealed S-2025-U1's orbit inclined relative to the equatorial plane, typical of Uranus's irregular moons, which are thought to be captured asteroids or fragments from ancient impacts. This discovery revives interest in Uranus's satellite system, dormant since Voyager's brief visit, and highlights JWST's role in revisiting outer planets with modern tech, where faint moons like this one, at magnitude 20+, evade ground-based telescopes. Uranus's moon system, now 29 strong, divides into major moons, like Miranda, with its chaotic terrain, and irregular outer satellites, of which S-2025-U1 joins the latter group, likely captured from the Kuiper Belt or scattered disk during the planet's formation or migration. These irregular moons, with prograde or retrograde orbits, cluster at distances of 50,000, 100,000 km, where S-2025-U1 resides, just beyond the Epsilon Ring's edge. The moon's small size, 10-kilometer diameter, roughly 90 football fields across, implies a low albedo surface, possibly icy or carbonaceous, reflecting only 5 to 10% of light, making it a stealthy neighbor. Its rapid orbit, completing a lap in hours due to proximity to Uranus's 51,118 km radius, aligns with tidal forces that could erode or reshape it over eons. El-Mutamid's team speculates S2025U1 might be a ring fragment or captured Kuiper object, providing clues to Uranus's violent history, a giant impact tilting its axis 98 degrees and perhaps disrupting its moons. This tiny satellite, visible in JWST's field alongside 9 of Uranus's 28 known moons, underscores the planet's understudied system, where half are small inner moons, suggesting a swarm of mini-satellites still awaits discovery. The significance of S2025U1 lies in its potential to illuminate Uranus's ring formation, as the moon's gravity could shepherd ring particles, maintaining their sharp edges or explaining gaps like the epsilon ring structure. Uranus's rings, discovered in 1977 by occultation and imaged by Voyager, are narrow and dark, composed of water ice mixed with silicates and organics, possibly remnants of a disrupted moon from a collision 4 billion years ago. S2025U1, orbiting outside the main rings, might act as a shepherd moon, similar to those in Saturn's system, using resonances to confine material, a hypothesis testable with future JWST or Hubble follow-ups tracking its position against ring arcs. The moon's discovery, amid JWST's NIRCam images showing 11 of 13 rings and polar clouds, revives calls for a Uranus orbiter, as NASA's 2023-2032 Decadal survey recommends, to probe these interactions up close. El-Mutamid emphasized that this small moon but a significant discovery, as it could explain ring longevity in a system battered by impacts, where tidal evolution might otherwise disperse them. This find, the first new Uranian moon in 22 years, highlights JWST's power for outer solar system reconnaissance, where faint, icy bodies like this one, at 620 light-years, blend into the zodiacal light without infrared sensitivity. Uranus itself, a pale cyan ice giant with 27 previously known moons, has long been an enigma since Voyager 2's 1986 flyby, which revealed its extreme 98-degree axial tilt, likely from a massive impact, and a featureless atmosphere hiding internal heat mysteries. The planet's moons, named after Shakespeare and Pope characters, e.g. Ariel, Umbriel, range from Miranda's fractured cliffs to Titania's craters, but the irregular outer ones like S2025U1 suggest capture or fragmentation origins. S2025U1's small size and position evoke captured asteroids, common in the Kuiper Belt's influence, where Uranus's migration scattered objects inward. The moon's orbit, inferred from its motion in JWST frames, lies in the plane of the rings, inclined 0.5 degrees to the equator, aligning with the planet's ring-moon system dynamics. Voyager missed it due to its faintness and proximity to the bright planet, but JWST's coronagraph blocks Uranus's glare, enabling detection at magnitude 20+. This addition bolsters theories of a collisional family, where a shattered progenitor moon supplied both rings and satellites, a scenario supported by 2025 simulations in Icarus, showing tidal resonances stabilizing small moons like this one. JWST's role in this discovery exemplifies its prowess for solar system studies, with NIRCam's wide-field imaging and spectroscopy capturing Uranus's rings in unprecedented detail, 11 of 13 visible including the faint Zeta ring, alongside 9 small moons and polar methane clouds. The telescope's infrared sensitivity, peering through atmospheric hazes that obscure visible light, revealed S2025U1 as a distinct point source, its icy surface reflecting sunlight weakly at 2 to 5 microns. El-Mutamid's team, including collaborators from Cornell and Southwest Research, processed the data to confirm orbital motion, distinguishing it from background stars or instrumental artifacts. This find, part of JWST's Cycle 3 observations, aligns with its goals for outer planets, where faint moons and rings demand high contrast ratios, 10:6.1. Future NIR-SPEC spectroscopy could analyze the moon's composition, likely water ice with organics, probing Uranus's volatile history, while MIRI's mid-infrared could detect thermal emissions from its surface. The discovery revives Voyager-era questions, like the planet's low heat flux, potentially linked to moon ring interactions dissipating energy. The broader implications for Uranus's system include potential swarms of mini-moons, as S-2025 U1's detection suggests JWST could uncover dozens more, given the planet's 27 irregular satellites hint at a disrupted past. Half of Uranus's moons are small inner worlds like this one, orbiting close to the rings where gravitational resonances might stabilize them or feed material into the system. The moon's size, 10 kilometers, implies it could be a captured Kuiper Belt object, similar to Triton, Neptune's moon, adding to evidence of outer solar system migration during planetary formation. This could explain ring origins, collisions grinding larger bodies into dust, with shepherds like S-2025 U1 maintaining structure. A Uranian orbiter, advocated in NASA's 2023 Decadal survey, could rendezvous with the moon, imaging its craters or plumes, but until then, JWST's annual checks will track its orbit for perturbations. El Mutamid's work, building on Voyager's legacy, positions S-2025 U1 as a key to unlocking the ice giant's secrets, where moons and rings intertwine in a delicate dynamic ballet. Uranus's rings, imaged alongside S-2025 U1, consist of 13 narrow bands of dark, icy particles, with the Epsilon ring the widest and most prominent, possibly confined by moonlets like this new find. The ring's low albedo, 5 to 10%, suggests contamination by meteoritic dust or tholins, organic hazes, from impacts, a theory S-2025 U1 supports if it's a fragment. JWST's images show ring structure in infrared, where thermal emissions reveal particle sizes, meters to kilometers, and the moon's proximity could explain kinks or waves via gravitational wakes. This discovery, the smallest Uranian moon yet, suggests a population of undetected mini-satellites, perhaps 100-plus kilometer-scale objects shaping the system. Voyager's 1986 data missed them due to resolution limits, but JWST's 0.1 arc-second clarity changes the game, potentially confirming ring shepherding models akin to Saturn's. As Tyson might say, Uranus rings aren't just pretty, they're a crime scene, and S-2025 U1's a suspect in the lineup. The hunt for more Uranian moons intensifies with S-2025 U1's find, as JWST's capabilities could reveal dozens in the outer system, especially irregular satellites captured from the Kuiper Belt. Uranus's 27 known moons include 5 large ones, Miranda to Titania, and 22 small, with S-22,000 Son, Hoi 2025, U1 joining the latter, orbiting at 50,000 kilometers, close enough for tidal locking but far from major influences. Future observations, perhaps with Hubble or JWST's next cycles, will refine its orbit and search for siblings, using difference imaging to spot motion against stars. The moon's composition, likely water ice with organics, could inform Uranus's formation, a giant impact tilting its axis and perhaps shattering moons to form rings. This discovery, amid renewed Uranus mission calls, positions S-2025 U1 as a catalyst for exploration, where small moons hold big secrets to ice giant evolution. S-2025 U1's diminutive stature belies its scientific punch, as its size, 10 km, makes it Uranus's smallest moon, comparable to asteroids like Bennu, 490 nanometers, but denser. If rocky or icy, its density, 1.5 GCM3, suggests porosity, surviving impacts that would pulverize denser bodies. Orbital speed, inferred from JWST frames, clocks 10 km/s, completing laps in hours, influenced by Uranus's oblate shape and rings drag. This moon's youth, perhaps billions of years old but dynamically recent, could reveal tidal evolution, where resonances with rings excite its orbit. El Mutamid's team plans follow-ups to track perturbations, potentially linking it to Epsilon ring arcs. In the grand scheme, S-2025 U1 exemplifies outer solar system diversity, where tiny worlds like this, missed by Voyager, await JWST's gaze, promising a fuller picture of Uranus's chaotic ballet. If this Uranian upstart has you rethinking the ice giant's mysteries, smash like, subscribe for more space scoops, and comment, what's next for Uranus missions? The rings are calling. Stay tuned for the encore. Science Tridaniber Pa and C.